Hello everyone and welcome to our session on data security in generative AI. As we know, generative AI models require large amounts of data to learn and create realistic outputs, whether that's images, text or audio. But with great data comes great responsibility. In this session, we will explore three core techniques that will help you safeguard your data sets and stay compliant with data protection regulations: access control, encryption, and dataset sanitization. Let's dive in. Well, we have already spoken in much details about the importance of data protection, 4.45 millions in data breach cost, and three core techniques. Let's move on to why data protection matters. In generative AI, data is the key ingredient. If your data is compromised or contains sensitive info, this can lead to huge problems. Legal and compliance risks. Laws like GDPR or CCPA impose strict rules on handling personal data. Brand and trust. If your system leaks user data, customers may lose confidence in your AI services. And model integrity. Altered or unsafe data can weaken your AI's performance and reliability. These issues are why data protection techniques should be on the top of your mind for everyone working with generative AI. Now let's jump into the first big technique, and that is access control. Access control is about deciding who can see, edit, or download which parts of your data. One of the most common methods is role-based access control, that is RBAC. In RBAC, roles, example admin, developer, data scientists, are defined based on job functions. Permissions are assigned to roles rather than individual users, and users inherit permissions through their assigned roles. For an example, admin can manage the entire data pipeline, including user permissions. Data scientists can view anonymized data but can't alter core configurations. And developers can modify model code but can't export full data sets. Benefits of RBAC: it simplifies management. You can quickly update a role permission without configuring each user individually. Second is ABAC, that is attribute based access control. On the other hand, grants permission based on user attributes like department, location, or security clearance. The rules: if a user's attribute matches a rule, example location is equal to headquarters, they get the access. Granular control: this can be more flexible than RBAC, especially in large organizations with diverse roles. A real world use case could be like a global tech firm might allow only employees located in specific data centers to access the raw data set, while remote employees can only access aggregated or anonymized versions. So the key takeaway: whichever one you choose, RBAC or ABAC, limiting unnecessary access to sensitive data is crucial for preventing accidental leaks or insider threats. Next up is encryption. Even if a malicious actor gains access to your storage media, encryption ensures they can't read the files. For that, you have file level encryption. Individual files are encrypted, typically with AES 256 or similar. And then you have disk level encryption. The entire disk or storage volume is encrypted, so if someone physically steals the drive, the data remains unreadable. For example, if you store your AI training data on a server, enabling full disk encryption like BitLocker on Windows or dmcrypt on Linux means an attacker can't simply mount the drive and copy your dataset. Encryption in transit: data can be intercepted while traveling across the network, and this is where encryption in transit comes in. TLS, transport layer security, for web connections like HTTPS, and VPN for secure tunnels between remote data centers or cloud services, and SSH, secure cell, for command line interactions with servers. Research from Verizon's data breach investigation report shows that a significant portion of breaches involve intercepted data transmissions. By default, always ensure your data flows are encrypted, and strong protocols like TLS 1.2 or above are there. Moving on to key management and best practices. An often overlooked aspect is key management. Storing encryption keys in plain text on the same server defeats the entire purpose of encryption. So you have some guidelines. Use secure key vaults, AWS KMS, Azure Key Vault, or on-prem solutions that handle rotation automatically. Rotate keys regularly, change them periodically, example every 90 days to reduce the risk, and limit key access only specific roles, example security admin should manage or see the encryption keys. With proper encryption at rest, in transit, and smart key management, you massively reduce the risk of your data being compromised. Now, the third technique is data sanitization, ensuring no one can identify real people or glean private details from your training data. Anonymization, replacing real names and emails with dummy identifiers or random strings, and pseudonymization, that is keeping some identifiers but delinking them from personal data. Reference: studies show that re-identification is possible with limited data points if not sufficiently sanitized. So through anonymization is essential. For example, suppose you are training a language model on customer support transcripts. Remove or mask phone numbers, addresses, and any specific personal details. This reduces legal liability and respects user privacy. You'll also want to filter out suspicious or unauthorized data entries. Perhaps someone uploaded copyrighted material or data that's outside your authorized usage scope. Next is combining techniques for robust data security. Individually, access control, encryption, and data sanitization are powerful techniques, but combining them creates a layered defense. Control: who can view or modify data with RBAC or ABAC? Encrypt that data at rest or in transit so it remains safe even if servers or networks are compromised. And sanitize your datasets to remove personal details or suspicious entries, reducing compliance risks and ethical concerns. Pro tip: review and update these measures regularly. Threats evolve, and so should your security practices. For more details on advanced configurations, do refer or explore NIST SP800 series, guides on encryption, access control, and key management, ISO IEC 27001, global standard for information security management, and open source tools, for example, Faker or Regex scripts, like we already discussed. Staying updated on best practices from these resources ensures your Gen AI data stays secure and compliant. To conclude, thank you for joining me in the exploration of data protection techniques for Gen AI. Remember, access control: assign users permission wisely. Encryption: keep data logged both at rest and in transit. And data sanitization: remove or anonymize sensitive entries. These three measures used together create a robust defense that not only guards your data but also maintains user trust and meets legal obligations. If you found, and that's all. So, should you have any questions, feel free to ask me in the Q&A section and I would be happy to help.